Hi, welcome. My name is Wissam. Today we're doing a demonstration of keeping evaluation contracts invariant as infrastructure evolves, from local execution to CI to isolated cluster workloads. The infrastructure changes, the quality gate doesn't. In parts 1 and 2, we ran the population nutrition eval and an agent routing eval. Today we run those same gates inside a Kubernetes job declared with Terraform on a local kind cluster. No hyperscaler bill, but the engineering question is the same one you'd ask in production. Can we change where and how we run checks without changing what pass means? Part 3 is infrastructure as code on a laptop. Declare desired state, a namespace and a batch job, apply it once, and then Kubernetes reconcile the runtime. We intentionally use a batch job instead of a deployment because evaluation is finite work. We want completion semantics, not long-lived reconciliation. The job runs the same eval scripts and pass-fail gates as the ones we ran in parts 1 and 2. Same logical contract, different execution environment. After the hands-on, we read the architecture as a narrative. Current system, where pressure shows up, first adaptations, and then eventual platform lift. With the same eval contracts at every phase gate. The expected outcome is population pass and agent eval pass inside the sandbox. Then tear the cluster down cleanly. So we'll walk through the lab, and the ultimate takeaway is that the lesson isn't the tool chain, it's that infrastructure should be reviewable before it's executable, and eval contracts should survive every runtime change. Okay, so let's walk through part 3, trust the gate. Doesn't cost anything. You don't have to create a cloud account or put in any credit card information, but you will have to clone the repo. Make sure that we have everything installed. Yeah, we have Docker. It helps to check. We're going to stand up the local kind cluster. The config mounts the lab repo inside the node. We're doing that as a lab shortcut so the job can run the eval scripts without building the custom image. In a real pipeline, evals run from the version container image in a registry. We're doing this for iteration speed. It's a deliberate lab trade-off, not a pattern to copy forward. We will create the local cluster and npm run platform cluster, and I will show you what this is doing. So if we go over to, no, you're not allowed to say I. We will show you what this is doing. So if we go to package.json, we'll see here what that script does. It says it uses kind to create cluster. So it runs this command with the name eval lab using this config that we have here, this YAML, and I'll show you that YAML. This kind config. So we're creating a cluster of this API version with this API version, this name, and it'll have only one single node with the role of control plane. And like I said, we're mounting the lab. Usually we would instead use a container image, like I said. But for the sake of the lab, we're just going to mount it. So we create the cluster. So output, you can now use your cluster. Status, the cluster in full, and it is running. If I click here, it'll just tell me that I don't have access to the cluster because we're just sending an unauthorized request. Now we move on to Terraform. So Terraform encodes infrastructure decisions as reviewable diffs. You declare what should exist, plan shows the gap between intent and reality, apply closes it. We use Terraform here, not a shell script of kubectl commands, because infrastructure should be diffable in pull requests, the same way application code is. Run init to initialize it, and then we'll run plan. Oh, so let me walk you through the folder here. With Terraform, we'll be using the main file to create the two resources that are remaining for that cluster that we just created. So we'll create the Kubernetes namespace here, and that namespace will be called eval sandbox, and then we'll also create the Kubernetes job within that namespace. So it'll be a pod with backoff limit 2, and the container inside will run the eval script. So the plan should say that there is going to be a Kubernetes namespace and a Kubernetes job that are going to be created in that cluster. So let's look. Yeah, so it says plan to add, 0 to change, 0 to destroy. So it'll create that namespace and it'll create also the job. And always read the plan before you apply. In a team setting, you'd use a remote state backend with locking so engineers don't corrupt shared state. Here it's local state. The workflow is what we're practicing. So we planned it. So now we know if we apply, what will happen. Yep, we saw one namespace and one job to add. So then we apply. And so it will create the namespace and the Kubernetes job. And so it will execute those, if this goes as planned, it will execute those evaluation scripts within that cluster. Apply complete. To added, 0 change. Let's do Terraform plan again, and then to see now, when we say no changes, so we see that already we have that namespace, that Kubernetes job, so we don't need to make any changes. This is idempotency. Rerunning apply safely does nothing when reality already matches your files. Let's see if our evaluation scripts have passed when we run them inside. The population seed has 100%. Are within the DGA band, so that is a pass because we need over 85% to pass. We have 100%, so we're passing, and then we have our hand curated personas that are also all passing. And so this shows that even running it through GitHub Actions and isolated is we will have those same results, same passing gates, regardless of where we run it, regardless of the infrastructure. The trade-off of running in cluster is isolation, so namespace separation from user serving workloads. You pay for that with scheduling delay. You also add another failure domain, mount paths, image pulls, cluster health, etc. So in Easton CI, you get workflow level retries on an ephemeral runner. In cluster, you get pod, restart policy, and cluster networking instead. But they're the same task, just different control planes. And why bother if CI already runs these scripts? Why bother to run them on the infrastructure? So eval gates belong in sandboxes that can't touch production traffic, and because infrastructure drift is a separate failure mode from model drift. So if we do kubectl get namespace eval sandbox, says it's active. Kubectl describe job eval gate. So we have our pod, the events, successful create, and job completed. So they created the pod and completed the job. So here, hopefully the takeaway is that infrastructure evolves, contracts shouldn't. So the same scripts should pass the same thresholds, whether they're run on GitHub Actions or Kubernetes. Let's destroy everything. We shouldn't leave Docker resources running when you're done. So let's run npm run platform destroy. If you see platform destroy, so we'll go here, platform destroy, and it just runs Terraform destroy, and then it deletes the cluster using kind. Two resources destroyed. Good job. So for the current system, we have our front end. We have the iOS, Android, web clients, and then we have the Node API on our Heroku backend. So right now, the Node API is a modular monolith. Here's a look at the different modules. So we have our platform module, well, you user timeline goals or profiles, and then the additional integrations that they can have, maps, news, wearables, their assistant module, which is all of the assistants, the chat, voice assistant, the scan module, anything to do with the vision, Google Vision. And although, yes, technically a Google Vision can be replaced with Amazon. The four logical domains are inside one API process, and there are no network hops between modules today. So the trade-off is a larger deployment blast radius. Transactions are simpler, the latency is lower, and there is a dramatically lower operational overhead. You don't pay for distributed system tax until distributed systems problems are actually yours. So you'll notice there's no Redis, no caching, because we don't have a caching problem yet worth introducing. There's no event bus today because synchronous execution is still simpler than eventual consistency. Um, we're just not there yet. So as we scale, uh, you know, what breaks first under load, usually the database under burst writes, and then LLM and Vision API quotas, and then synchronous heavy work blocking other routes. So user count in this case is not treated as a scaling metric. Advancement is driven by operational metrics. If latency exceeds a sustained budget, we buffer and add back pressure before we split services. The first response is always buffering, rate limits, item potency, not jumping straight to microservices. So here we have the conceptual scale. Um, Dash is what is a future aspirational. Solid is today. So we have the edge and the firewall. We route to the correct service. We can also take a look at how it would look if it was on GKE. So we start with the cloud CDN, path-based routing. And then we have our four core services on microservices. We have Redis for ephemeral cache, external systems, these are the managed AI services or data. And then we have our, for event-driven infrastructure, we'll have our event bus with PubSub and the workers. And for now, Superbase for auth and Postgres, although we would eventually have to, split up the databases and cloud storage. So on Kubernetes, AI is just another workload class, same cluster, different scheduling. It's not a reason to operate your own model stack with managed APIs still fit. And the important lesson isn't modularity, it's preserving contracts while changing implementation. Today, we're running on Heroku. We pick a cloud control plane when metrics justify a platform lift. So Kubernetes and microservices are not in production today. This is a conceptual evolution path when scale metrics justifies phase changes. So today we have that modular monolith on Heroku. We want to harden those modules and timeline events. There's some hardening that does need to be done. We move to that buffered monolith with the queues and the workers, and then go into that event-driven infrastructure, and then eventually optional service splits. A quick note on drift. So there's two types of drifts that ScanAndFindIt covers. We treat both of them. Neither replaces the other. We cover both machine learning drift and infrastructure drift. So we do the evals for machine learning drift, and then we also do Terraform plan to cover that infrastructure drift. So yeah, good architecture. It's not measured by how many technologies appear on a diagram. It's measured by how long you can delay complexity without sacrificing correctness. So today's system is intentionally a modular monolith. Tomorrow's system may not be. What shouldn't change are the contracts that, so we practiced one piece of that today, eval scripts that passed locally and passed in an isolated cluster job, declared with reviewable infrastructure, torn down cleanly, infrastructure evolved, and the gate didn't. So thanks for building with integrity. See you in the next one. And don't forget to download the app, Scan and Find It on iOS or Android.